In this paper, we present Mixwell, a family of sharp 2D fluid brushes for real-time physics-based mixing of quasi-static ideal fluids. Here, our optimized Mixwell GPU implementation shows progressive evaluation of complex fluid marbling patterns using combs, allowing interactive exploration of design parameters at real-time frame rates. Mixwell fluid deformations are evaluated independently per sample, enabling truly progressive fluid mixing simulation without global solves, grids, or intermediate texture resampling. Mixwell leverages analytic flow evaluation so users can pan and zoom freely, and the mixing stays sharp and resolution independent. Mixwell brushes are derived from classical solutions of a cylinder moving through an ideal incompressible fluid. As the cylinder passes, nearby material is dragged along and experiences a net drift. Our sharp 2D Mixwell flow brush preserves area, produces the characteristic cusp-like pull near the brush tip, and removes the cylinder mathematically. The Mixwell brush directly evaluates the reverse drift needed for texture advection. For longer brush strokes, such as line segments or curves, we must integrate the flow numerically and/or analytically. To abstract away numerical details and simplify modeling, we introduce reverse drift functions, or RDFs. For example, analytically integrating an infinite stroke leads to an efficient line RDF that is widely used in marbling patterns. Numerically integrating a finite stroke leads to a line segment RDF. Line segments can be used to build a more complex triangle wave primitive. These can be combined to produce combs, and those combined to simulate complex patterns. For repeated patterns, exploiting periodicity and intermediate samples can significantly reduce costs. This birdwing benchmark has two expensive periodic triangle wave combs. Exploiting periodicity yielded a 21 times speedup in sample generation. Curves can be approximated by numerically integrating the Mixwell brush. This example shows an infinite grid of circle RDFs. Here, sine wave RDFs are used to simulate a comb at costs comparable to a tri-wave comb. Mixwell also supports progressive 3D rendering. These marbled scarves are rendered in Houdini with Redshift OSL shaders. Users can interactively adjust simulation parameters to find a suitable design. Finally, Mixwell supports arbitrary-resolution zooms for high-resolution fluid renders. Pinch and twist Mixwell brushes can be derived using the affine brush framework. Image brushes can be used to approximate rigid slip boundary conditions.